Okay, we're still talking about square roots, and in particular square roots that work out to be irrational numbers. And we'll look at some examples of how to simplify these. And the first one is the square root of 75. The technique here is to take the number that you're trying to square root and try to factor the number, and try to find factors that are perfect squares. So 75, for example, is 25 times 3. So let's write it that way, 25 times 3, and note that 25 is a perfect square. 25 is 5 squared, or in other words, the square root of 25 is 5. So instead of a 25 under the radical, that's equivalent to a 5 outside of the radical. So I imagine these perfect square factors like this popping out from under the radical. And instead of a 25 under there, I now have a 5 out front. So the answer is 5 times the square root of 3. And 3 can't be factored. I can't find any perfect square factors of 3, so that's my answer. Note that I could have done this, and this wouldn't have been good. I could have said 75 is 5 times 15. But that doesn't help me. I can't square root the 5, and I can't square root the 15. So instead of factoring it like this, factoring it as 25 times 3 is more helpful. You want to try to find factors, like the 25 we found there, that are perfect squares. So here's another example. The square root of 200. Well, 200 is 20 times 10, but it also can be written as 100 times 2. And this is a better way to factor it right here, because that 100 is a perfect square. You all know that 10 squared is 100. So think of it like this. Think of the square root of 100 is 10. So instead of the 100 underneath the radical, I can imagine that 100 popping out front as a 10. And the 100's gone, and I have a 10 out front instead. So the answer is 10 times the square root of 2. Here's another example. The square root of 12. Okay, 12 is 4 times 3. So this is the square root of 4 times 3. And when I write this, I leave a little space out here. That comes in handy. The 4 becomes a 2 out from under the radical. The square, in other words, the square root of 4 there, a 4 under the square root, is equivalent to a 2 not under the square root. And I end up with 2 times the square root of 3. The square root of 12 is mathematically the same thing as 2 times the square root of 3. And these are considered simplified over here when they're like this. If you get into a form where you can no longer find any perfect square factors under the radical, then and only then is it simplified. Another example, square root of 63. Well, 63 is 9 times 7. So the square root of 63 is the square root of 9 times 7. And 9 is 3 squared. In other words, the square root of 9 is 3. So the 9 pops out of here and becomes a 3 outside of the radical. So I end up with 3 times the square root of 7 as my answer. Okay, a few more examples here. The square root of 80. Okay, how can we write that? Well, 80 is, let's see, it's 8 times 10. It's also 20 times 4. Let's do this. Let's do 8 times 10, and then let's factor each of those. 8 is 4 times 2, and the 10 is 5 times 2. Now look what happens here. The 4 is a perfect square, so it can pop out front as a 2. And this 2 times 2 is another 4. So those guys together are going to pop out front as another 2. So I'm going to end up with 2 2's out here multiplied together. And the only thing left underneath is that 5. So I end up with a 4 out front. This 2 times this 2 times the square root of 5. Okay, the next example, square root of 128. This one's pretty easy. 128 is 64 times 2. And 64 is 8 squared. So the 64 pops out of here and becomes an 8. And I get 8 times the square root of 2 for an answer. Okay, 1800. Don't be intimidated by large numbers under the radical. They get small real fast when you start to square root them. If you don't know what to do on a problem like this, start by trying to find perfect square factors. Just try to factor it. 1800 we know is 18 times 100. And look there, there's a perfect square factor, 100. But note the 18. 18 can be factored some more. 18 is 2 times 9. So let's write this as 2 times 9 times 100. Now, the 9 pops out of here as a 3, and the 100 pops out of here and becomes a 10. So I have a 10 times a 3 times the square root of 2. So my answer is 30 times the square root of 2. And the square root of 1350, 1350. How can I factor 1350? Well, I know it's a multiple of 50, so let's figure that out. If you need to pull out the calculator, you can. That comes out to 27 times 50. Now, that doesn't help too much, but let's keep going here. 27, I know, is 3 times 9. So this is 3 times 9, and 50 is 5 times 10. And the 10 there, the 10 can be factored again. So let's write this as 3 times 9 times 5, and then instead of the 10 we have 5 times 2. So all of that is under the radical. And you can see some things that are going to happen here. The 9 is going to pop out of there and become a 3. And this 5 times 5, that's a 5 squared, or a 25. Those two 5s multiplied together, or the 5 squared right there under the radical, is equivalent to a 5 outside of the radical. So we have a 3 and a 5 when we square root this and that. And so we end up with a 15 out front, and the 3 and the 2 factors underneath. So 15 times the square root of 6. And we often read that as 15 root 6. That is the simplified version of my original problem over here. Okay, and those are some examples of that technique. You should practice that some more in the practice problems, but that is the method. Find perfect square factors and bring those out from under the radical, square rooting them in the process.